Hello, in this lecture we'll find out the length of line segment X using two different methods. In the drawing we have quadrilateral ABCD. We know that side AD equals to 3 units, side AB equals to 5 units, side DC equals to 6 units, angle ADC, this angle equals to 90 degrees, angle ABC equals to angle DCB equals to theta, and we want to find out the length of line segment, the length of side BC. This is actually X, according to what is given as the question. So we'll start with the first method. In the first method, we will extend line segment BA and line segment CD by a straight line until they intersect with each other. We will define the intersection point between extended line segment AB and extended line segment CD as E. So here we created triangle EBC. In this triangle EBC, those two angles are equal to each other, they are both equal to theta. So in the next step I will present to you a new rule. This is actually rule number 1. According to rule number 1, in front of equal angles in the triangle, there are equal sides. I will read rule number 1 again. According to rule number 1, in front of equal angles in the triangle, there are equal sides. So we relate to triangle EBC. In this triangle EBC, we know that angle ECB equals to angle EBC. So angle EBC is equal to angle ECB, and they are both equal to theta. I'll repeat again. In the big triangle ECB, angle EBC equals to angle ECB, and they are both equal to theta. Therefore, according to rule number 1, we get that EB is equal to EC. EB is equal to EC. This will be question number 1. According to rule number 1, of course, because of the fact that sides EB and side EC are located in front of the equal angles EBC and ECB, they are also equal to each other. That is to say, EB equals to EC according to rule number 1. So here, EB equals to 5 plus AE. and EC equals to 6 plus ED. So here we will subtract 5 from this equation number 1, and we'll get that according to equation number 1, AE equals to 1 plus ED. AE equals to 1 plus ED. So we'll define ED as A. Here ED equals to A according to our definition. We'll substitute ED by A in this equation number 1, and we will get that according to equation number 1, AE equals to 1 plus ED, and ED equals to A according to our definition. So in conclusion, we found out that A equals to 1 plus A. AE equals to 1 plus A. Can I write here that AE equals to 1 plus A? So here we have quadrilateral ABCD. In quadrilateral ABCD, line segment DC is one side of quadrilateral ABCD. So line segment CD as a side of a quadrilateral must be a straight line. So CD is a straight line, and then when we extended the straight line CD by a straight line, we got line segment CE. And when you extend a straight line by a straight line, the result must be a straight line also. So CE is a straight line. So can I tell that CE is a straight line? Line segment CE is a straight line. Because when you extend a straight line by a straight line, the result must be a straight line. So the result of extending the straight line CD by a straight line is CE. Therefore, CE is a straight line. So C is a straight line, and we have rule number 2. According to rule number 2, according to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. I'll write it down. The sum of the angles on one side of a straight line is equal to 180 degrees. I'll read rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line EC at point D, then the sum of the angles here must be equal to 180 degrees. So which angles we have at point D? Which angles we have at this side of the straight line EC at point D? We have here 90 degrees. This angle equals to 90 degrees according to what is given in the question, plus this angle, that is angle ADE. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. I'll repeat again, the sum of the angles at one side of the straight line C at point D is 90 degrees plus angle ADE, and according to rule number 2, the sum of those two angles in total must be equal to 180 degrees. We'll subtract 90 degrees from this equation. And we'll get that the missing angle ADE equals to 180 degrees minus 90 degrees, it is 90 degrees. So this angle is a right angle, that is to say it is equal to 90 degrees. So if angle ADE is a right angle, it means that triangle ADE is a right triangle. So we will implement the Pythagoras theorem on the right green triangle, triangle ADE. Okay, according to the Pythagoras theorem, in the right green triangle, triangle ADE, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse is AE squared and it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to AD squared plus ED squared. I'll repeat again. In the right triangle, the right green triangle, triangle AED, according to PT is the progression for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AE squared. Here it is AE squared must be equal to AD squared plus ED squared. So according to Pythagoras theorem, we get that AE squared equals to AD squared. AD is 3 units, so AD squared is 3 squared, that is 9, plus ED squared. ED is A, so ED squared is A squared. So, in conclusion, we found out that according to equation number 2, AE squared equals to 9 plus A squared. AE is 1 plus A, so A squared is 1 plus A squared. Equals to 9 plus A squared. I'll repeat again. According to equation number 2, 1 plus A squared equals to 9 plus A squared. Here we will open the brackets on this side of equation number 2 and we will get that 1 plus A squared, it is equal to 1 plus A squared plus 2A, and it is equal to 9 plus a squared. Here we have a squared on both sides of equation number 2, so a squared will get cancelled. And what is left from equation number 2 after we cancelled a squared? What is left is that in this side of equation number 2 we have 1 plus 2a, and it is equal to 9. Here we'll subtract 1 from this equation, equation number 2, and we'll get that according to equation number 2, 2a equals to 9 plus 9 minus 1 is 8, so 2a equals to 8. We will divide this equation number 2 by 2, and we will get that according to equation number 2, a equals to 8 over 2 is 4. A equals to 4. So actually found out that a equals to 4 units. Therefore 1 plus a is 5 units. In the next step we'll focus on the green right triangle, triangle AD. We'll define angle AED. This angle is alpha. So in the right green triangle, triangle AD, cosine alpha equals to ED over EA. I'll repeat again. On the green right triangle, triangle AD, cosine alpha equals to ED over EA. Here ED equals to 4 and EA equals to 5, so in conclusion I found out that cosine alpha equals to 4 over 5. Cosine alpha equals to 4 over 5. Okay. In the next step, I will present to you a new law, and we will implement the law in this big triangle, triangle ABC. The new law is the law of cosines. The law of cosines is true in any triangle. So if we have triangle ABC, that could be any triangle, this is triangle ABC. The length of side AB is A units, the length of side AC is B units, and the length of side BC is C units, and the angle between side AB and side AC is alpha. Then according to the law of cosines, we will get that C squared equals to A squared plus B squared minus 2 times A times B times cosine alpha. Okay? This equation is true in any triangle. Therefore, we will implement the law of cosines in our triangle, triangle ABC. Again, C squared equals to A squared plus B squared minus 2 times AB times cosine alpha. We will implement the law of cosines in this triangle, this big triangle, triangle ABC. In this triangle, A equals to EB, A equals to EB, but EB equals also to 5 plus 5, that is 10. Here B equals to EC, B equals to EC, but EC equals to 4 plus 6, 4 plus 6, that is also 10. And C equals to BC, that is also equals to X. And we've already found out that cosine alpha equals to 4 over 5. Here we've already found out that cosine alpha equals to 4 over 5. So according to the law of cosines, C squared is BC squared, equals to A squared is EB squared, plus B squared is EC squared, minus 2 times EB times EC, times cosine alpha, and we already found out that cosine alpha equals to 4 over 5, so we'll substitute cosine alpha by 4 over 5. So BC is 10, so BC squared is 10 squared, it is 100. No, actually BC equals to X. Here BC equals to X. Therefore BC squared will be equal to X squared. And it is equal to EB squared. EB equals to 10, so EB squared is 10 squared, that is 100. So this is equation number 3. Plus EC squared. EC equals to 4 plus 6 is 10, EC equals to 10, so EC squared is 10 squared, that is 100 also. Minus 2 times EB is 10, EC is also 10, times 4 over 5. So according to equation number 3, we will get that X squared equals to 100 plus 100 is 200, minus 10 times 10 is 100, 100 times minus 2 is minus 200, and here we have also times 4 over 5. So actually, according to equation number 3, we found out that X squared equals to 200 minus 200 times 4 over 5. So here, according to equation number 3, X squared equals to 200. Here we have minus 200 over 5 is minus 40, and we have to multiply it by 4, of course, also. So here, according to equation number 3, we found out that X squared equals to 200 minus 40 times 4 is minus 160. So we found out that according to equation number 3, x squared equals to 200 minus 160 is 40. Here we'll take a root out of this equation, equation number 3, and we'll get that x equals to the square root of 40. 40 is 4 times 10, so we substitute 40 by 4 times 10. The square root of 4 is 2, so in conclusion, we found out that x equals to 2 times square root of 10 units, so in terms of numbers, it is equal to 6.32 units. Okay? I'll repeat again. Here, side BC that is equal to x, it is equal to either 2 times square root of 10 units, or in terms of numbers it is equal to 6.32 units. Okay, so we finished with the first method. In the next step I will present to you how to find out the length of line segment BC that is equal to x according to the second method. So in the second method, we will do another construction. From point A, we will draw a straight line on DC in such a way that the straight line will be parallel to BC. Okay? We will define the touching point of the straight line from point A and DC as E. I will repeat again that we drew the straight line in such a way that AE will be parallel to BC. So you can write here that you can write here that AE is parallel to BC according to our construction. In the next step, we will do another construction from point E. We will draw a straight line on BC in such a way that the straight line will be parallel to AB. Okay? We will define the touching point on the straight line from point E and BC as F. I will repeat again that we drew the straight line from point E and BC in such a way that EF will be parallel to AB. So here EF is parallel to AB according to our construction. So in quadrilateral AEBF, we have two couples of lines that are parallel to each other. AE is parallel to BF and AB is parallel to EF. And this is exactly the definition of a parallelogram. Therefore, quadrilateral AEBF is a parallelogram. Okay? Any quadrilateral that has two couples of sides that are parallel to each other is defined as a parallelogram. Therefore, quadrilateral ABF is a parallelogram. In the next step, I will present to you a new rule that is actually rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. So I'll read rule number 2 again. According to rule number 3, of course, I will read rule number 3 again. According to rule number 3, corresponding angles between parallel lines are equal to each other. Here, side AB is parallel to side EF according to our construction. Therefore, those two angles that are defined as corresponding angles that are located between the parallel lines A, B, and EF will be equal to each other according to rule number 3. That is to say, angle ABC equals to angle EFC. Angle ABC equals to angle EFC according to rule number 3. But angle ABC, this angle equals to theta according to what is given us in the question. This angle equals to theta according to what is given us in the question. And from this equation, theta equals to angle ABC equals to angle EFC, we will derive that angle EFC is also equals to theta. So this angle equals to theta. Likewise, AE is parallel to BF, AE is parallel to BC according to our construction. Again, here AE is parallel to BC according to our construction. Therefore, because of the fact that AE is parallel to BC, those two angles are defined as corresponding angles that are located between the parallel lines AE and BC, therefore they are equal to each other according to rule number 3. That is to say, this angle is actually angle AED. Is equal to this angle, that is angle DCB. And they are equal to each other according to rule number 3. But this angle DCB equals to theta, according to what is given us the question. This angle equals to theta. So from this equation, angle AEB equals to angle DCB equals to theta, we will derive that angle AEB is also equals to theta. So this angle AEB equals to theta. In the next step, I will present to you a new rule that is actually rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. I'll write it down. I will read rule number 4 again. According to rule number 4, the opposite sides of a parallelogram are equal to each other. So we will relate to our parallelogram, parallelogram AEBF. If we focus on parallelogram AEBF, we know that its opposite sides are equal to each other. That is to say, AB is equal to EF, AB is equal to EF according to rule number 4, this rule. But AE equals to 5 units according to what is given us in the question. So we can write here that AB equals to 5 units. And from this equation 5 equals to AB equals to EF, we will derive that EF is also equals to 5 units. EF is also equals to 5 units. So here we can write down that EF equals to 5 units. In the next step, we will focus on triangle EFC. In triangle EFC, we know that those two angles are equal to each other, they are both equal to theta, therefore they are equal to each other. So angle EFC is equal to this angle that is actually angle ECF, and they are both equal to theta. I'll repeat again. Angle EFC equals to angle CF and they are both equal to theta. Therefore, according to rule number 1, side EF will be equal to side EC. EF equals to EC. EF equals to EC according to rule number 1, that in front of equal angles in the triangle there are equal sides. Therefore, side EF equals to side EC. According to rule number 1. But we've already found out that EF equals to 5 units. So we can write here that EF equals to 5 units. And from this equation 5 equals to EF equals to EC, we will derive that EC is also equals to 5 units. EC is also equals to 5 units. Here EC equals to 5 units. So what is the length of the short line segment DE? It is very easy to see from the drawing that DE equals to DC minus EC. I'll repeat again. DE equals to DC minus EC. So DE equals to DC equals to 6 units according to what is given in the question. And we already found out that EC equals to 5 units. So in conclusion, DE equals to 6 minus 5, that is 1. So DE equals to 1 unit. So right here that DE equals to 1 unit. Now we'll focus on the right green triangle ADE. We will implement the Pythagoras theorem on the green right triangle ADE. On the green right triangle ADE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. The square of the hypotenuse is AE squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to AD square plus DE square. I will repeat again. In the green eye triangle ADE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AE square must be equal to AD square plus DE square. So AE square, according to question number 1, AE square must be equal to AD square. AD equals to 3, so AD square is 3 squared, that is 9, plus DE square. DE equals to 1, so DE square is 1 squared, that is 1. So, in conclusion, we found out that according to equation number 1, AE square equals to 9 plus 1, that is 10. Here we take out of this equation number 1, and we will get that AE equals to the square root of 10 units. So we can write here that AE equals to the square root of 10 units. Now we will use rule number 4 in parallelogram ABF. According to rule number 4, the opposite sides of a parallelogram are equal to each other. So in parallelogram AEBF, AE equals to BF. According to rule number 4, of course. So, in parallelogram, P is the expression for parallelogram. So in parallelogram ABF, side A equals to side BF, according to rule number 4, that states that the opposite sides of a parallelogram are equal to each other. AE equals to BF, but AE equals to 5 units, according to what is given us in the question. AE equals to square root of 10, according to what we have already found out. A equals to square root of 10 units. And from this equation, square root of 10 units equals to AE equals to BF. We will derive that BF is also equals to the square root of 10 units. So here BF equals to the square root of 10 units. So what is the length of side FC? The length of side FC, for the drawing, it is very easy to see that FC equals to BC minus BF. Again, BC minus BF equals to FC. Again, here, FC equals to BC minus BF. BC equals to X, according to what is given us as a question. And we just right now found out that BF equals to the square root of 10 units. So, in conclusion, we actually found out that FC equals to X minus square root of 10 units. So, we can write here that FC equals to X minus square root of 10 units. Here, FC equals to X minus square root of 10 units. Okay? In the next step, we will focus on triangle EFC. So, triangle EFC is an isosceles triangle because of the fact that EF equals to EC. I'll repeat again. Triangle EFC is an isosceles triangle because side EF equals to side EC of triangle EFC. And we also know that FC is the base of the isosceles triangle, triangle EFC. FC is the base of the isosceles triangle, triangle EFC. I'll repeat again. FC is the base of the isosceles triangle, triangle EFC. In the next step we will do a construction. From point E, we will draw perpendicular on FC. Well, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point E and FC as M. So here EM is perpendicular to FC. And if you have a line segment that is perpendicular to any side of a triangle and it exists from the vertex of the triangle, it means that this line segment is the height to that side. In this case, this line segment EM is the height to the base FC. So this is the height to the base FC. So I can write here that line segment EM is the height to the base FC. Again, line segment EM is the height to the base FC of the isosceles triangle, triangle EFC. So, in the next step, I will present to you a new rule that is actually rule number 5. According to rule number 5, the height to the base in an isosceles triangle bisects the base. So write it down, the height to the base in an isosceles triangle bisect the base. So I'll read rule number 5 again. According to rule number 5, the height to the base in an isosceles triangle bisects the base. So here we will relate to the isosceles triangle, triangle EFC. Here, according to rule number 5, the height EM to the base FC bisects the base FC. So that is to say, the height EM divides the base FC into two equal parts. That is to say, FM equals to MC according to rule number 5. Okay, so here we relate to triangle EFC, the isosceles triangle, triangle AFC. According to rule number 5, this rule, FM equals to MC. This is according to rule number 5, this rule of course. So according to rule number 5, the height bisects the base. That is to say it, divide it into two halves. So if the first part is the first half, that is to say, if this is Fm equals to Fc over 2, then the second part, Mc, will be also equals to Fc over 2. Why? This is the minimum of bisects. When the height bisects the base Fc, it means that it divides it into two halves. So the first half is Fm and the second half is Mc. So in conclusion, here Fm equals to Fc over 2 and Mc also equals to Fc over 2. In conclusion, Fc over 2 equals to Fm equals to Mc according to rule number 5. That is to say, Mc equals to Fc over 2. Fc equals to x minus square root of 10, according to what we have already found out. Fc equals to x minus square root of 10, and if we divide it by 2, we'll get Mc. So in conclusion, Mc equals to x minus square root of 10 over 2. So you can write here that Mc equals to x minus square root of 10 over 2. Okay? In the next step, we will prove that those two right triangles are similar to each other. So this, the green triangle EMC, is similar to the small green triangle AED. First of all, in the green right triangle EMC, this angle equals to 90 degrees, this angle equals to theta. So this angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. So in order to complete the sum of the angles in triangle EMC to 180 degrees, this angle must be equal to 90 degrees minus theta. In this right triangle AED, this angle equals to theta, this angle equals to 90 degrees. So this angle must be equals to 90 degrees minus theta for the same reason exactly. Okay, so first of all, we actually found out that those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So write it down. We'll prove the small right green triangle ADE is similar to triangle EMC. The small and the big right green triangle EMC. So why they are similar to each other? First of all, this angle EAD, is equal to this angle that is actually angle MEC, and both angles are equal to 90 degrees minus theta, therefore they are equal to each other also. So I'll repeat again. Angle AED equals to angle MEC, and they are both equal to 90 degrees minus theta, therefore they are equal to each other. In addition, we have those two angles that are both equal to theta, therefore they are equal to each other. So this angle that is actually angle AED is equal to this angle that is actually angle ECM, and they are both equal to theta, therefore they are equal to each other. So here angle AED equals to angle ECM equals to theta, and finally those two angles, they are both right angles, therefore they are equal to each other. So angle ADE, this angle equals to this angle, it is a triangle EMC, and they are both equal to 90 degrees. I'll repeat again. Angle ADE equals to angle EMC equals to 90 degrees. So actually we found out that all the angles of triangle ADE can go into all the angles of triangle EMC, therefore those two triangles are similar to each other according to angle similarity rule. So I will write it down. So triangle ADE is similar, this is the sign of similar to triangle EMC according to angle similarity rule. And from the fact that those two right green triangles are similar to each other, hence we'll conclude that AE over EC is equal to DE over MC. I repeat again, from the fact that the two right green triangles are similar to each other, we conclude that AE over EC equals to DE over MC. AE equals to the square root of 10 units, EC equals to 5, and here DE equals to 1, and MC equals to x minus square root of 10 over 2. So, in conclusion, we found out that according to equation number 2, square root of 10 over 5 equals to 1 over x minus square root of 10 over 2. Here we will move 2 to the numerator and x minus square root of 10 to the denominator on this side of equation number 2, and we will get that according to equation number 2, square root of 10 over 5 equals to 2 over x minus square root of 10. Here we will cross multiply this equation number 2, and we get that according to equation number 2, square root of 10 times x minus square root of 10 equals to 2 times 5 is 10. Here we substitute 10 by square root of 10 times square root of 10, and we'll get that according to equation number 2, the square root of 10 times x minus square root of 10 equals to square root of 10 times square root of 10. Here we will divide this equation number 2 by square root of 10, and we will get that according to equation number 2, x minus square root of 10 equals to square root of 10 times square root of 10 over square root of 10 is square root of 10. Here we will add square root of 10 to this equation number 2, and we will get that according to equation number 2, x equals to square root of 10 plus square root of 10 is 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay? So here, x, BC that is equal to x, it is equal to either 2 times square root of 10 units, so in terms of numbers it is equal to 6.32 units. So we finish with the first method. In the next step I will summarize the lecture. We'll start with the first method. I will repeat on the question. We have quadrilateral ABCD. Side AD equals to 3 units, side AB equals to 5 units, side DC equals to 6 units, angle ADC equals to 90 degrees, angle ABC equals to angle DCB equals to theta, and we want to find out the length of line segment BC that is actually equals to x. Okay, so first of all we did a construction. We extended side BA and side CD by straight line until they intersect with each other at point E. Point E is the intersection point of the extended side AB and the extended side CD. Okay, so created here triangle EBC. In triangle EBC we have those two angles that are equal to each other. They are both equal to theta, therefore they are equal to each other. Then I presented to you rule number 1. According to rule number 1, in front of equal angles in the triangle there are equal sides. So we relate to triangle EBC. In triangle EBC, angle EBC equals to angle ECB equals to theta. Angle EBC equals to angle ECB equals to theta. Therefore, according to rule number 1, in front of those two equal angles there are equal sides. That is to say, EB equals to EC. But EB equals to 5 plus AE. EB equals to 5 plus AE. And EC equals to 6 plus ED. EC equals to 6 plus ED. We subtracted 5 from this equation number 1, and found out that A equals to 1 plus ED. A equals to 1 plus ED. Then we defined ED as A, and we substituted ED in equation number 1 by A. So here ED equals to A according to our definition. Here we substituted ED by A in this equation number 1. So here A equals to 1 plus ED and ED equals to A. So in conclusion, found out that according to equation number 1, A equals to 1 plus A. Here A equals to 1 plus A. Then I presented to you, first of all, here, before we did the construction, we had the quadrilateral ABCD. In quadrilateral ABCD, CD or DC is one side of the quadrilateral ABCD. So if a side of a side of a quadrilateral, it must be a straight line. CD is the side of a quadrilateral, therefore it must be a straight line. And after we extended the straight line CD by a straight line, the result is CE, so the result must be also a straight line, because when you extend the straight line by a straight line, the result must be a straight line. So when we extended the straight line CD by a straight line, the result is CE, therefore it must be a straight line. So we can write here that CE is a straight line, and we have rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So here, if we focus on this side of the straight line CE or EC at point D, then the sum of the angles here must be equal to 180 degrees. So which angles we have at this side of the straight line EC at point D? We have here 90 degrees and we have angle ADE. In total, the sum of those two angles must be equal to 180 degrees. So at one side of the straight line CE at point D, the sum of the angles must be equal to 180 degrees. So which angles we have at point D? At point D we have 90 degrees plus angle ADE. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation and we found out that the missing angle ADE equals to 90 degrees. This angle equals to 90 degrees. Therefore, the green triangle is a right triangle. We implemented the Pythagoras theorem on the green right triangle, triangle ADE. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AE square equals to AD square plus AD square. AE square equals to AD square plus AD square. So AE square equals to AD square. AD equals to 3, so AD square is 3 squared, that is 9, plus ED square. ED is A, so AD square is A square. So in conclusion, we found out that A square equals to 9 plus A square. A equals to 1 plus A, so we substituted AE by 1 plus A, and we found out that according to equation number 2, 1 plus A square equals to 9 plus A square. We opened the brackets on this side of equation number 2 and found out that 1 plus A square is 1 plus A square plus 2A, and it is equal to 9 plus A square. We have A square on both sides of equation number 2, so A square will get cancelled, and we left only with 1 plus 2A, that is equal to 9. According to equation number 2, we subtracted 1 from this equation number 2, and found out that 2A equals to 8. We divided this equation number 2 by 2, and we found out that A equals to 4 over 8 over 2, that is 4. So here we found out that A equals to 4 units, therefore A plus 1 equals to 5 units. Then we defined, in the green right triangle AD, we defined angle AD is alpha. So here cosine alpha in this green right triangle will be equal to ED over AE. Okay, cosine alpha equals to ED over EA. ED equals to 4, EA equals to 5. So in conclusion, we found out that cosine alpha equals to 4 over 5. Then I presented to you the law of cosines, and we implemented the law of cosines in this triangle EBC, the big triangle EBC. So actually the law of cosines is true in any triangle. So here triangle ABC can be any triangle. Side AB equals to A units, side AC equals to B units, and side BC equals to C units. Then according to the law of cosines, C square equals to A square plus B square minus 2 times A times B times cosine alpha. Okay? We implemented the law of cosines in this triangle EBC. Here A equals to EB, but EB also equals to 5 plus 5, that is 10. B equals to EC, but EC equals to 4 plus 6, that is also 10. So B equals to EC, and EC also equals to 10 units. C equals to BC, and BC equals to X. And we already found out that cosine of alpha equals to 4 over 5. So according to the law of cosines, we will get that BC square, C square is BC square, it is equal to EB square plus EC square minus 2 times EB times EC times cosine alpha. But cosine alpha is 4 over 5, so we substitute cosine alpha by 4 over 5. Okay, so here BC equals to X, so BC square is X square, and it is equal to EB square. EB is 10, so EB square is 10 squared, that is 100, plus EC square. EC is 10, so EC square is 10 squared, that is also 100, minus 2 times EB is 10, times EC is also 10, times cosine alpha, that is 4 over 5. So according to equation number 3, we found out that X squared equals to 100 plus 100 is 200, minus 10 times 10 is 100, times minus 2 is minus 200, times 4 over 5. So in conclusion, found out that according to equation number 3, x squared equals to 200 minus 200 times 4 over 5. Okay? So according to equation number 3, x squared equals to 200 minus 200 times 4 over 5. 200 over 5 is 40. So here we found out that according to equation number 3, x squared equals to 200 minus 40 times 4. So x squared equals to 200 and minus 40 times 4 is minus 160. So according to equation number 3, x squared equals to 200 minus 160 is 40. So x squared equals to 40. We took out of this equation number 3, and found out that x equals to the square root of 40. 40 is 4 times 10, so we substitute that 40 by 4 times 10. The square root of 4 is 2. So in conclusion, we found out that x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Here, x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. We finished with the first method. Then I presented to you how to find out the length of line segment BC that is equal to x according to the second method. In the second method, we did another construction. From point E, we drew a straight line on DC in such a way that AE is parallel to BC. In the next step, from point E, we drew a straight line on BC in such a way that EF will be parallel to AB. Therefore, we created here parallelogram. Parallelogram is quadrilateral that has two couples of sides that are parallel to each other, exactly like this parallelogram ABF. Okay, then I presented to you rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. So here, according to our construction, AB is parallel to EF, AB is parallel to EF. Therefore, those two angles that are defined as corresponding angles that are located between the parallel lines AB and EF will be equal to each other according to rule number 3. I'll repeat again. Because of the fact that AB is parallel to EF according to our construction, we will get that angle ABC equals to angle EFC according to rule number 3. But angle ABC, this angle equals to theta according to what is given us as a question. So from this equation, theta equals to ABC, to angle ABC equals to angle EFC, we will derive that angle EFC equals to theta. This angle EFC equals to theta. Likewise, according to our construction, AE is parallel to BC. AE is parallel to BC, therefore those two angles that are defined as corresponding angles that are located between the parallel lines AE and BC will be equal to each other according to rule number 3. Here angle AEB will be equal to angle BCD according to rule number 3. But angle BCD equals to theta according to what is given us in the question. So from this equation, theta equals to angle BCD equals to angle AEB, we will derive that angle AEB is also equals to theta. This angle AEB equals to theta. Then I presented to you rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. So we will relate to our parallelogram AEBF. According to rule number 4, its opposite sides are equal to each other, that is to say AB equals to EF. Okay, in parallelogram ABF, AB equals to EF according to rule number 4. But here AB equals to 5 units according to what is given as the question. So we can write here that AB equals to 5. So from this equation 5 equals to AB equals to EF, we will derive that EF is also equals to 5 units. EF is also equals to 5 units. Then in triangle EFC, those two angles are equal to each other, they are both equal to theta, therefore they are equal to each other. So angle EFC equals to angle CF equals to theta. And therefore, according to rule number 1, that in front of equal angles in the triangle there are equal sides, we get that EF equals to EC, according to rule number 1. But EF equals to 5 units, according to what we have already found out. EF equals to 5 units, and from this equation 5 equals to EF equals to EC, we derive that EC is also equals to 5 units. EC equals to 5 units. So, what is the length of the short line segment DE? From the drawing it is very easy to see that DE equals to DC minus EC. Okay? So here DE equals to DC minus EC. So DE equals to DC, that is 6 units, minus EC, that is 5 units. So DE equals to 6 minus 5, that is 1. So DE equals to 1 unit. Now we implemented the Pythagoras theorem on the green small right triangle, triangle ADE. The square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, AE square equals to AD square plus DE square. So AE square equals to AD square, AD equals to 3, so AD square is 3 squared, that is 9, plus DE square. DE equals to 1, so DE square is 1 squared, that is 1. So in conclusion, we found out that AE square equals to 9 plus 1, that is 10. We took out of this equation number 1, and found out that AE equals to the square root of 10 units. Here, AE equals to the square root of 10 units. Then we used rule number 4, that the opposite sides of a parallelogram are equal to each other. That is to say, here parallelogram ABF, its opposite sides are equal to each other. That is to say, AE equals to BF, according to rule number 4. But we just right now found out that AE equals to the square root of 10 units. So from this equation, the square root of 10 units equals to AE equals to BF. We will derive that BF is also equal to the square root of 10 units. Here, BF equals to the square root of 10 units. So what is the length of side FC? From the drawing, it is very easy to see that FC equals to BC minus BF. Again, FC equals to BC minus BF. Okay? FC equals to BC minus BF. BC equals to X, according to what is given as the question. We just right now found out that BF equals to the square root of 10 units. In conclusion, we found out that FC equals to X minus square root of 10 units. So we can write here that FC equals to X minus square root of 10 units. Okay, then we focused on triangle EFC. In this triangle EFC, first of all, triangle EFC is an isosceles triangle. Why? Because side EF equals to side EC. Again, triangle EFC is an isosceles triangle because of the fact that EF equals to EC equals to 5 units. And FC is the base of triangle, the isosceles triangle, triangle EFC. FC is the base of the isosceles triangle, triangle EFC. And from point E, we draw perpendicular on FC. We define the touching point of the perpendicular from point E and FC as M. So actually EM is perpendicular to FC. So what is line segment EM? Because of the fact that line segment EM is perpendicular to FC, it means that EM is the height to the base FC. Okay, EM is the height to the base FC. Again, EM is the height to the base FC. Then I presented to you rule number 5. According to rule number 5, the height to the base in an isosceles triangle bisects the base. So if you focus on triangle EFC, the height EM to the base FC of the isosceles triangle EFC bisects the base FC. That is to say, it divides the base FC into two equal parts. That is to say, Fm equals to Fmc. According to rule number 5, Fm equals to Mc, but the sentence bisects the base. It means that it divides this into two halves. So each part equals to Fc over 2. If we divide this to two halves, it means that each part equals to Fc over 2. That is to say, Fm equals to Fc over 2, and Mc also equals to Fc over 2. So according to rule number 5, in the isosceles triangle EFC, Fc over 2 equals to Fm equals to Mc. Okay? So from this question, we derive that Mc equals to Fc over 2, Fc equals to x minus square root of 10. And if we divide it, if we will divide Fc, if we divide Fc by 2, we'll get Mc. So Fc, that is x minus square root of 2 divided by 2, is Mc. That is to say, Mc equals to x minus square root of 10 over 2. Okay? Here, Mc equals to x minus square root of 10 over 2. Then we proved that the big right green triangle EMC is similar to the small right green triangle AED. Why those two triangles are similar to each other? First of all, in the green right big triangle EMC, this angle equals to 90 degrees, this angle equals to theta, so this angle must be equal to 90 degrees minus theta. In order to complete the sum of the angles to 180 degrees, this angle must be equal to 90 degrees minus theta. For the same reason, this angle must be also equal to 90 degrees minus theta. So those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. Okay? So angle EAD equals to angle MEC, and they are both equal to 90 degrees minus theta, therefore they are equal to each other. In addition, those two angles, they are both equal to theta, therefore they are equal to each other. And finally, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So actually we found out that triangle, the green right triangle AD is similar to the green right big triangle EMC according to angle similarity rule. And from the fact that those two green right triangles are similar to each other, we will derive that AE over EC equals to DE over MC. I'll repeat again, according to equation number 2, AE over EC equals to DE over MC. AE equals to the square root of 10 units, EC equals to 5, DE equals to 1, and MC equals to x minus square root of 10 over 2. Okay? Here we will move the 2 to the numerator and x minus square root of 10 to the denominator, and we will get that according to equation number 2, square root of 10 over 5 equals to 2 over x minus square root of 10. Here we will cross multiply this equation, equation number 2, and we will get that according to equation number 2, square root of 10 times x minus square root of 10 equals to 10. We substitute the 10 by square root of 10 times square root of 10 because square root of 10 times square root of 10 equals to 10. And we got that square root of 10 times x minus square root of 10 equals to square root of 10 times square root of 10. We divided this equation, equation number 2, by square root of 10, and we found out that according to equation number 2, square root of 10 times square root of 10 is 1, so we left in this side of equation number 2 only with x minus square root of 10. And in the other side we have square root of 10 times square root of 10 over square root of 10 is square root of 10. So in conclusion, found out that according to equation number 2, x minus square root of 10 equals to square root of 10. We added square root of 10 to this equation, equation number 2, and we found out that x equals to either 2 times square root of 10 units, or in terms of numbers it is equals to 6.32 units. So here, side BC that is equal to x, it is equal to either 2 times square root of 10 units or 6.32 units. So in both methods, we arrived to the same result for the side BC that is equal to x. Okay, thank you very much.